Have you ever wondered how the lights stay on? We flip a switch and just like magic, our rooms fill with light. But where does all that energy come from? Sometimes it travels from a place very, very far away across hundreds of miles, deep beneath the ocean waves. This is the secret world of subsea power cables, the unseen superhighways that carry electricity between countries. These aren't just simple wires. They're technological marvels, built to survive the crushing pressure and harsh conditions of the deep sea. Imagine gigantic cables as thick as your arm, resting silently on the ocean floor, carrying massive amounts of power between nations. This hidden network is one of the most amazing feats of modern engineering, allowing countries to share energy and making our power grids stronger. When one country has extra power, say from wind turbines on a blustery day, it can send that clean energy to a neighbor who needs it. Subsea cables are essential for our transition to renewable energy, solving the problem of the sun not always shining and the wind not always blowing. They create a giant international grid, moving clean energy from where it's generated to where it's needed most. It's like a super smart extension cord stretching across oceans, ensuring clean power gets to our homes and cities no matter the weather. So, next time you look out at the ocean, remember, beneath the waves lies a powerful, invisible network shaping our modern world. These cables are the unsung heroes of our electrical grid, working day and night to keep our planet powered up. They're a testament to human ingenuity and our ability to solve big problems with even bigger ideas. Let's dive in and explore how these incredible cables are built, laid, and how they're powering our future. Get ready to be amazed. End scene. Why go to all the trouble of laying massive cables across the ocean floor? It's all about teamwork and smart energy sharing. Subsea power cables let countries trade electricity just like neighbors sharing food at a potluck. For example, the UK's wind farms and Norway's hydropower plants can swap energy through the North Sea Link, the world's longest subsea power interconnector. When the UK has extra wind power, it sends it to Norway, which saves its hydropower for later. When the wind calms, Norway sends clean hydropower back. This exchange helps both countries reduce fossil fuel use and prevents blackouts. A win for energy security and the planet. As the world adopts more renewables, balancing the grid becomes critical. Subsea cables let solar farms in Spain or geothermal plants in Iceland share power across borders. These interconnectors unlock the full potential of green energy, building a flexible, resilient, continent-spanning power grid. By 2030, the market for high-voltage subsea cables will be worth billions, showing just how vital they are to our global energy strategy. This interconnected grid also drives down costs for consumers, creating competition and lowering prices. So these cables aren't just engineering marvels, they directly impact our wallets and our environment. They're a practical solution to fighting climate change, ensuring stable energy and making electricity more affordable. When we work together, we build a brighter, more sustainable world. End scene. What's inside a deep-sea power cable? If you sliced one open, you'd find a multi-layered marvel built for extreme conditions. At the core are thick copper or aluminum conductors, chosen for their ability to carry huge amounts of electricity over long distances. Surrounding the conductors is a critical layer of insulation, super clean polymers that keep the high-voltage current safely contained. Next comes a metallic sheath, often lead or aluminum, forming a waterproof barrier and providing electrical grounding. This sheath keeps water out and ensures safe operation, even after decades on the seabed. Then comes the armor, thick steel wires wound tightly to protect against fishing trawlers, anchors, and rocky seabeds. The rougher the seabed, the thicker the armor. For deep, calm waters, the armor is lighter. For busy coastal areas, it's incredibly robust. The final layer is a tough outer skin, usually polypropylene yarn, binding everything together and protecting against corrosion. Every layer has a job: conducting, insulating, sealing, shielding, and protecting. It's a tough, resilient design for a tough, demanding environment. These cables are built to last, quietly powering our world from the ocean floor. End scene. Building a subsea power cable is a precise, high-tech process inside massive factories. It starts with huge spools of copper or aluminum, bundled into a thick, uniform conductor. Next, the conductor is pulled through a towering extrusion machine where insulation is applied in a dust-free environment. Any imperfection could cause failure years later. After cooling, the cable receives its metallic sheath, either molten lead or welded aluminum, creating a seamless, waterproof barrier. Then, dozens of steel wires are wound around the cable, forming a protective armor. Finally, the assembly is coated in a tough, bitumen-soaked polypropylene layer. The finished cable is massive and heavy, sometimes dozens of kilometers long, and is carefully coiled onto giant turntables. Every step combines chemistry, metallurgy, and robotics on an epic scale. The result, a cable ready to face the ocean's harshest challenges. End scene. Once built, the cable's next challenge is reaching the ocean floor, handled by specialized cable-laying ships. These floating factories have giant carousels holding thousands of tons of cable, loaded from the factory over days or weeks. Equipped with advanced dynamic positioning systems, these ships hold their exact route even in rough seas. Laying a cable is about precision, not speed. Every meter is carefully placed along a pre-surveyed path. Before sailing, surveyors map the ocean floor in detail, avoiding cliffs, volcanic vents, and busy anchorages. The ship follows this digital roadmap, seeking smooth, stable paths where the cable can be buried for protection. Missions can last months, with crews working around the clock, monitoring every meter as it disappears into the sea. These ships are self-contained worlds, connecting continents and delivering the power that fuels our lives. End scene. Laying a power cable on the ocean floor is a delicate dance of heavy machinery and high technology. The cable is fed off the ship's carousel, through tensioners, and over the lay wheel, arcing down to the seabed. Tension must be perfect. Too much and the cable stretches, too little and it kinks. In shallow, busy waters, a sea plow buries the cable beneath the seabed, protecting it from anchors and fishing gear. Engineers monitor everything in real time from the ship's control room, using live video from underwater robots. These ROVs check placement, inspect the sea plow, and can even make minor repairs deep below. Once the cable reaches shore, it's pulled through a conduit to a landfall station and connected to the grid at a converter station. Here, high-voltage DC is converted back to AC for homes and businesses. The unseen energy highway is ready, silently linking two lands together. End scene. The deep sea is hazardous, and even the toughest cables face threats. Human activity is the biggest danger. Ship anchors and fishing gear cause most cable faults. That's why cables are buried in busy areas, but accidents still happen, leading to costly repairs. Natural hazards like underwater landslides, earthquakes, and abrasive currents can also damage cables. In geologically active regions, routes are planned to avoid unstable slopes. Recently, deliberate sabotage has become a concern. These cables are critical infrastructure and potential targets. Governments now monitor key routes with patrols and surveillance. When a cable is damaged, repair ships use ROVs to locate the fault, lift the cable, and technicians splice it back together on board. The process can take weeks and cost millions. Protecting these lifelines is more important than ever. End scene 13. Demand for deep-sea power cables is set to skyrocket as we push for a clean energy future. The next frontier connecting massive offshore wind farms and energy islands to multiple countries via supersized cables. Projects like the X-Links Morocco-UK Power Project and Australia's Sun Cable will stretch thousands of kilometers, redefining what's possible. With more cables comes a greater need for protection. Fiber optics inside cables now monitor temperature, strain, and even detect nearby anchors. International cooperation is increasing, with nations working together to secure these vital sea lanes. The future of energy isn't just about generating it cleanly, it's about moving it smartly. Subsea cables are the key to a global, resilient green grid. They'll connect the sunniest and windiest places with the cities that need power, stabilizing prices and accelerating our move away from fossil fuels. The silent network growing on our ocean floors is one of the most important engineering stories of our time. End scene. We've journeyed beneath the waves to uncover the secrets of subsea power cables. These technological marvels are built to survive the ocean's harshest environments, layer by layer. We've followed cable-laying ships as they stitch continents together with these energy lifelines. Subsea cables are the backbone of our clean energy transition, enabling international cooperation and a more stable, efficient power system. By sharing renewable energy across borders, we reduce waste and accelerate our move away from fossil fuels. But these vital arteries are vulnerable to accidents, sabotage, and the challenges of repair. As our reliance grows, so must our efforts to protect them. Next time you turn on a light, remember the incredible journey electricity might have taken to reach you. The story of subsea cables reminds us that some of the most important innovations are the ones we can't see. They are our planet's hidden lifelines building our electric future. End scene.